Okay, so on example number 3, you're actually evaluating composition functions, which means that we actually have numbers that we are going to plug in. When it's written in composition form instead of in function notation form, well, it's all function notation, but in this specific form, the best way to think about it is you're going right to left. So I'm going to evaluate G of 3 first. So G of 3 is what's going to be evaluated. So that means I'm going to go to x equals 3. On G, though, find its output, and the output here is 1. So now I know G of 3 equals 1. Then I'm going to take the solution from that and plug it into F. So now I'm finding F of 1. So I'm going to go to function F, go to x equals 1, go out on its output, and that puts me at 2. And so now my final answer is where I stop at. So the final answer is 2. Okay, when you're written in function notation form, you work your way from the inside to the outside. So we have G of 1. So this time we're finding G of 1 first. So I'm going to go to graph G, go to x equals 1, find its output, and the output is 3. Now I'm going to go to F of 3. So I go to function F, go to 3, its output is 2. So my final answer is 2. Okay, now that is what you did in Algebra 2. Now you're in pre-cal. So pre-cal just involves more operations while evaluating. So here I have double composition. And so I'm going to start from the inside. So we have G of 4. So I'm going to go to G of 4 first. So G of 4, the output is 0 times, and then I have F of 1. I'm going to find that. So F of 1. I'm going to go to F, go to 1, and the output is 2. Now I'm going to find F of 0. So I go to 0 on F, and then the output is 4. And then I'm going to go to G of 2. So I go to 2 on G, and its output is 2. So 4 times 2 is 8 would be my final answer. Okay. I have F of -1 divided by F of G of 3. Okay. So again, you're starting with the innermost here, and this one, the numerator has its own. So F of -1. So I go to F -1, and we get 6. I'm going to go to G of 3. So I go to G, go to 3, and I get 1. Now to keep evaluating, I'm going to find F of 1. So I go to F, go to 1, and the output is 2. And then I simplify. 6 divided by 2 is 3. Okay. I'm going to leave you to practice E and F. Be mindful. If you don't have a value for something, then that's just no solution. It's undefined. So if one input leads you to nothing that is given to you, then you have no choice but to say that it's not defined. Okay. Yeah. So that's example number 3. Example number 4. We're decomposing the function. So if we're decomposing, we're trying to figure out what 2 functions make this function, okay? So in the case here, we have h of x equals f composed of g of x. So g of x is going to be our inside. So we're going to find our g of x of each one of these. And we're going to find our h of x and our f of x, I'm sorry. In the purest form, when you're doing this, your f of x is simply going to be generally the parent function of the outside. Like what is the most basic thing that would have created this, okay? All right, so looking at your inside. So on A, our inside is x plus 3. So x plus 3 is our inside. If I was to replace x plus 3 with just x, my outside would be x squared. Okay, for a rational, your inside is looking at your denominator. So our denominator is x minus 5. My inside is x minus 5. If I was to replace x minus 5 with just an x, it would be the rational function of 1 over x. For the square root, looking on the inside, our inside is x plus 2. If I was to replace x plus 2 with just the variable x, I would be left with the square root of x. Okay, for this quadratic here, we're looking and seeing what value they have in common, and the value that they have in common is x minus 2. So our inside is x minus 2. If we were to replace each x minus 2 with an x, we would be left with x squared minus 4x plus 5. Okay, so now moving on, here we have the square root of 3x squared plus 1. And it says to create two different ways, right? It says a composition of functions, okay? I'm gonna leave you to decide. The two ways that I would have you think of is think about what could you have plugged in, what could have already been there, what could the original been, and there are multiple ways. So this is left for you to try, and I believe you'll do just fine. Okay, lastly, applying compositions to a real world problem or an application of some sort. So it says here, Jim plants wheat on his farm in Kansas. The function W of A gives the amount of wheat W in bushels that he expects to harvest if he plants wheat on an acres of land. When the wheat is harvested, Jim can calculate the amount of money M in the dollars that he will earn from selling W bushels of wheat with the function M of W. Okay. So M of W is what we're looking for in terms of WA. So in the case of here, W equals WA. So explaining the meaning of W of 5, 275. Well, remember our first function, it's in terms of our WA equals the amount of wheat, right? That's our amount. Amount of wheat in bushels. And bushel, right? So in terms of this, your A is going to be what? Your acres, right? So for W acres, so when I'm interpreting this, I have to identify what each variable is. So here I know that A equals 5 and W equals 275. So when I'm writing what this means, I'm saying, all right, for 5 acres, it will have 275 bushels. Does that make sense? So for 5 acres, there will be 275 bushels. Okay. Then it says here, explain what this means. So in terms of this problem, it says M65 equals 550. Well, now we're looking at the second equation. The second equation is M stands for your money in dollars that he will earn from selling W bushels of wheat with the function, right? So when we look at M of W, that's what's explaining our money, our dollars that we're going to earn, So in this case, your 65 represents what? Well, your 65 is representing your W. So we now know that W equals 65 bushels. Right? So we have 65 bushels. And then we know that our output is going to be our M, and our M in this case would be 550. So what does that mean? It says if he sells, so if he sells 65 bushels, he will make $550. Okay, so putting it all together, explain what this means. So coming from the inside and working your way out, what is happening here? What is the W of 5 representing? 4 representing, and then its output represents in terms of M. I'm going to leave you to challenge and try and do that yourself. And then if you have questions or you haven't figured it out, we will talk about it. But the challenge is for you to try, and then it may appear as a do now for you to input your trials. All right, that is it. Thank you for being awesome. And that's the end of the section.